Welcome to STEM Professionals. In this video, we'll discuss the questions based on the chapter 1, and the level of questions would be easy. So the questions will be based on the following topics. The first one is dimensional analysis. The next one, scalars and vectors. And finally, the unit conversion. So let's start with the video. So as of now, we have discussed the concepts of chapter 1 in detail. And now we're going to discuss the questions based on the concepts that we studied. So the first question on your screen now. So this is your first question, and in this question we have to tell that can the dimensional analysis determine that the area of the circle is given by pi r square or 2 pi r square? Now actually the answer would be no. The concept of dimensional analysis cannot determine that the area of circle is pi r square or 2 pi r square, and the reason is that here the factor 2, this factor 2 is dimensionless. There is no dimension for this factor 2. So the answer would be no. Now this is our next question, and there are two parts in this question. In the first part, they are saying that is it possible for two quantities have same units but different dimension? So we're going to solve the A part first. Now we're going to take two physical quantities. We can take velocity, and another one we can take speed. Now they have same units, so unit we have to take the same, that is we can take kilometer per hour, and here also kilometer per hour. These are the units. Now but different dimension. But if you see the dimension for velocity, we know it is L over T, that we discussed earlier also, and here also the dimension will be length over time. So if unit is same, dimension should also be same. So it will not be different. So this is no. The answer would be no. This is not possible. So this is the answer for the A part. Now next we can discuss the B part. Now in this question, in this part they are saying that is it possible for two quantities have same dimension but different units? So here also we can take these same physical quantity, that is velocity and speed. Now here this dimension is same, that is length over time. This is same, and here also length over time. But the units, now velocity is measured in meter per second also. It can measured in kilometers per hour, or you can take in feet per second, anything you can take. And here also speed can also be in meter per second, kilometer per hour, feet per second, anything you can take. So this dimension will be same but units can be different. So yeah, this is correct. The B part is correct, so we can write yes, this is correct. So this is our next question, and in this question they are saying that Albert runs 34 meters to the right in 10 seconds. So this one is Albert is moving towards the right direction, and it travels a distance of 34 meters within time frame equals to 10 seconds. On the other hand, Isaac runs 17 meters to the left. So distance covered is 17 meters and direction is towards the left side. This is left side and this is right side, and time taken is 5 seconds. Now there are two parts in the equation. We're going to solve for the A part first. Now in the A part they are saying that is Albert's speed greater than, less than, or equal to Isaac's speed. So first of all you should know what is speed. Speed is the distance traveled in the given time. So speed is distance over time. This is a basic definition. So distance is 34 meter. I'm talking about this Albert's. So SA we can write. Divide with time is 10. So that is equals to 3.4 meter per second. And if you find the speed of Isaac, so it will be equals to 17 over 5, and that is also equals to 3.4 meter per second. That means the speed of Isaac is equals to the speed of speed of Albert is equal to the speed of Isaac. So we can write that for A part, Albert's speed is equals to Isaac's speed. Now next in the B part they are saying, is Albert's velocity equal to Isaac's velocity? Now we know that velocity is a vector quantity. A vector means direction plus the magnitude. Now the magnitude is same, that is 3.4, but direction is different because the Albert is moving to the right side and Isaac is moving to the left side. Therefore we can write that velocity of Albert is not equals to the velocity of Isaac. Now next few questions will be based on the unit conversion. The first question is, the movie The Hunger Games brought in about $152 million in its opening weekend. Now we have to express this amount in gigadollars and in teradollars. So first of all, you should know the unit conversion, that is 1 gigadollar. It means 10 to the power $9, and 1 teradollars, it means 10 to the power $12. So the amount we have is this much. This is 152 and 6 times zeros. Now we have to convert this into gigadollars for the A part. So this is dollar. Now we know that 1 gigadollar is 10 to the power $9. So from here we'll get this value to be 0.152 gigadollars. Now next we can solve the B part in the same fashion. So this is 152 6 times 0. Now this time in teradollars. So we know that 1 teradollar is 10 to the power $12. So that will be equals to 1.52 times 10 to the power minus 4 teradollars. So this is our next question, and in this question it is given that the speed of light in a vacuum is approximately 0.3 gigamiles per second, and we have to express the speed of light in meter per second. So for this you should know the unit conversion, that is 1 giga miles per second. It means 10 to the power 9 meter per second. So we can write this is 0.3 giga miles per second, sorry, gigameter per second. So 1 gigameter per second, it means 10 to the power 9 meter per second. So from here we can see that this one will cancel it out and we are left with the units in meter per second. So this we can write as we can take 110 to this side, so 3 times 10 to the power 8 meter per second. So this is the answer in meter per second for the speed of light. So this is all with this video, and in the coming few videos we'll discuss few more questions based on chapter 1. Thank you.